Hello everyone and welcome back to this natural language processing projects on company location selection criteria. And from this video on, I'm going to explain in detail how each test has been conducted in this project. So I'm going to introduce some code in Python, hope to give you an expression. Okay, so in this video, I'm going to explain the data exploration and pre-processing on training data, which is the first step of this project. So without further ado, let's take a look of what the data I'm going to process look like. So we see here that I have 4 data sets. So the first one is the 120 article that are most related to the location criteria, and the last 3 are the ones that are not as closely related as those to 100 that are related to the company location selection criteria. So let's click on this first one to see what it looks like. So basically it looks like this. So it is an HTML file, and we have 120 articles in here. You see here, this is document 1 out of 120, and here we have this 2 out of 120, and all these articles are separated by this line here. So if you look at this second, third, and fourth, the 3, we can form this testing data set. Let's see what this look like. So it basically look like the same. So we have 1,000 articles in here, and they are all separated by a line. And there are also in this HTML file. So now you have this impression of what the data look like here. So now let's go to Python code. First, what I normally want to do is I import this NumPy and Panda package. Those packages are the ones that we will commonly use, and then I import all these 4 files to Python. So they're all in the HTML file, and there is particular methods for you to import HTML file into Python. Here I use CodeCS package, and I use in scripts get text to read the text data in those files. So basically, with this, I can import all these files into Python. It's gonna take you some time, but it should be very quick. Okay, now we imported all this data. Just have a brief review of what the train data set look like. So you see here that I stored this 120 articles to a file called train, and also those 3 files I stored them into first 1,000, second 1,000, and the last 789. So I stored them in these 3 names. So let's look at what this train looked like. So this train is basically the 120 that we want to, that are mostly related to the criteria. Okay, so we can see here that Python can read all this text data in here. So you see that this is document 1 out of 120, which is the same with the data set here. But for here, if we wanted to separate this 120 articles, we need to find out a way. So the way that I find out, the easiest way that I find out, is to separate these articles based on a same stream that's shared by each of these articles. What I decided to do is, if we take a look at the data set, that we can see that at the end of this at the end of each article, there's a stream called this, like database AB/inform trade and industry. So we can separate or we split these articles with this string here. The reason why I don't use this line here is because Python just cannot detect this line. Just cannot detect this line. And the reason why I do want to split this file into individual articles is because the later models that I'm going to use are based on the comparisons across these articles. So I cannot just analyze this whole file as one article. It will actually lose some accuracy of the analysis. So for here, if we search a document in here, in here, I see, for example, this document 2 out of 120. We can just see here like this splitting point of document 1 and 2. So we see here. This is the database and line, and this line here. So Python cannot. You can see here, Python cannot detect this line. There's no way that I can split this file by this line, but I can split the file by this string here. If you look at document 2 and 3, you can see that there is also this same string. So this method actually works. So I just use this method. So well, this string actually appears across all these 4 files. So I use the same method to split all these 4 files. So let's see what will happen with this step. So you see here, I split all these 4 files by this string. And I see that the first file was split into 121, second 997, third 989, and the fourth 787. So it's actually pretty good. It's pretty good split. We lose a very small amount of articles because the first one is exactly correct. It should be 121. And the second, we lost the four or 3 articles. They could combine together because it should be 1001, and the third should also be 1001. So we lost 10 something articles. They could combine together, and in those ones that there could be not this string. There could not be this string there, but it actually will not affect the final result to a large extent. So this method actually works. And then, because these 3 files are all testing data, I wanted to merge them together. So with this step, I kind of merged these 3 files into one file called test data. Let's see what. So let me print out this length of the training data. So in this training data, I have 121 articles, and in testing data, I have 2,773 articles. So this is pretty ideal. This is what I want. Now let's do some training or the data cleaning part of the training data set. So first, I wanted to convert this this training data set to a data frame. So with the data frame, that I can see that in each row I put a document into each row. So each row represents a document. But we can see here, and we can also see in our previous step that this data is actually pretty dirty, pretty and not the one that we wanted to process. So we actually need to do a lot of cleaning in here. But we see here that there are some characters at the beginning and at the end of the article that we are actually not interested in. For example, that in here, like all these characters before this full text are actually we actually don't want them. We want to get rid of them, and the ones that from this subject from industry, these characters, we also want to get rid of them. And actually we must get rid of them, because if we don't, because these are all repeated words in each article, if we don't get rid of them, it will kind of make you in trouble while you are analyzing the results, because our formula models are based on the word frequencies. So we must get rid of them. The reason, the means, the method I did this is I removed the first 1000 and like 1291 characters, and the last 1083 characters. And then I have a cleaner data set. So you see here, after I do this step, I remove the first 1000 something characters, just to start from somewhere on the full text, which is like the prose of this article, which is the ones that we are interested in. And then after that, I do some basic text cleaning, which is this part. Basically, I transfer the characters into lower cases, remove the links, and remove punctuations, and remove stop words, remove numbers, and delematize all the words. So you see here, after this step, it looks like this this text has been much cleaner than before. See, I don't see any punctuations, and I don't see any special characters that I don't want. And then I do some customized cleaning. So I don't want those single letters. I don't want the month word, and I don't want the number words. So I want to remove them. So after I remove them, it becomes cleaner. It becomes cleaner. So like see here, this is the first 10 lines, which is the first 10 documents in here. But how about we look at just the first article? So if we just print the first articles, we will see that it will look like something. It will look like this. So we can see it's pretty clean. It's the one that we want in here. And after this this text cleaning, the training data set, the mission for this training data set is to train a phrases model, to let the model know, to let the model learn what kind of 2 words or 3 words could form a phrases. And in those phrases, we're interested in those phrases together with those terms to decide a certain kind of criteria. So in this step, I use the Genzium's models, the phrases and phrasers model to to detect the phrases. So in this step, I can run this step. Basically, for this step, I train a model called the multigram, and with this model, I will use it to test on my testing data. So in that data, in that step, it will help me to detect those phrases in my texting data. So in this step, is actually a learning process. It tells the computer what kind of words could form a phrase. So here I set the threshold to 3. Basically, I want the computer to learn the words that combine together, like up to 3 words that combine together could form a phrase. So this is how this model has been trained. Okay, and this is this part of this video. Thanks for watching.